Yeah, very good afternoon to each and every one of you. I hope my voice is loud and clear. Can you please, anybody confirm whether I'm audible
Yes,
or
sir.
not?
Yes, Irfan, you're loud and clear. Thank you.
Yeah, thank you, Akanksha, for confirmation. So we are crossing 190. Yeah, I request all the professors and dear faculty members, please ask your colleagues, friends to join the session at the earliest so that we can start on time. Chandana, can you please share our scroller?
Yes, sir. I'll share.
Yeah. Again, I request all the professors who are already in the room. So please inform to your colleague, your friends to join the session at the earliest. Okay. We have crossed 200. So let us wait a few more minutes so that we can start the session. Yeah, so my dear faculties, we just crossed 250. Let us wait one or two more minutes so that we can proceed. Chandana, can you please post our Zoom link in the chat box so that our other faculty members will get informed about the session.
Yeah, sure, Irfan. I'll share.
Dear faculty members, we are also running this faculty development program on YouTube. We are also live on YouTube. So if anybody getting a technical glitch to get into this Zoom session, they are suggested to please switch to YouTube Live. We have shared the Zoom link and YouTube link in the chat box. Please refer those links. Yeah, we are heading to 300 now. So good to go. So Akanksha, let's get started then. Akanksha, are you there? Chandana, am I audible?
Yeah, Irfan, you're audible.
Okay. Okay, so it's
Yeah.
yeah. Okay.
Yes, Irfan.
Yeah.
Yeah.
Yes, Akanksha.
Sure.
So Akanksha, okay. So shall we proceed then?
Yes, please proceed.
Okay. Yeah, we are almost at 300 now. Okay. Let me share my screen first. I hope my screen is visible.
Yes, Irfan, it is
Yeah.
visible.
Yeah. Thank you. Yeah. Before I come to the introduction of XLR, so I again welcome all the faculty participants in this National Faculty Development Program on NLP, Computer Vision, and Artificial Intelligence, Series 2. We already have done with our Series 1 program, and this is a Series 2 program. From APSSDC side, so I am very thankful to Dr. Ravi Gujala, sir, who is CGM Technical, APSSDC. I'm also thankful to Dr. Siva, who is a FDP coordinator. And from our end, we have with us today our TDM Assistant Manager, Akanksha Modi, then our LMS Administrator, Miss Chandana. Yeah, so let's get started. So before I dive into the actual session, I just wanted to tell you about who we are and what we are doing in this training programs. So it's an honor to address you today about XLR, a pioneering company in the training and consulting space. Throughout the years, we have extended our reach globally, providing high quality classroom and online training to students as well as faculty members through these faculty development programs. So our headquarter is in USA, Houston. along with our strong presence in Malaysia and India. So in India, we are operating from 6 locations. Bangalore is our headquarter. Then from Hyderabad, we are operating. From Mumbai, we are operating. From Mumbai, from 2 locations, we are operating. One is from Andheri, another is in Thane. From Pune, we are operating from 2 locations. And we are recently operating from Chennai, Tamil Nadu, which reflects our commitment to transcending geographic boundaries, making a top-notch education accessible to all of you. So the expertise of our passionate team spans various domains such as data science, artificial intelligence, uh, Internet of Things, cloud computing, so on and so forth. Having successfully trained numerous individuals worldwide. I mean, we trained students, faculties, and working professionals. At XLRs, we uphold a commitment to excellence in all aspects, from the quality of our training programs to the support we offer to our students and faculties and colleges also. Whether you are a student or a faculty member, okay, I mean, some of the participants are maybe students of final year students also joined this program. So it doesn't matter whether you are a faculty member or a working professional aiming to advance your career or upskill your knowledge. We have a tailored training programs for you in the form of SDP, in the form of FDP, in the form of Ignite programs. So these are the programs we are continuously running for our stakeholders. So for this purpose, I appeal to I request to all the faculty members who are in the room, they can visit to our website at www.xlr.com. And you can also follow us on our various social media platforms like LinkedIn, uh, Instagram, Facebook. So, Chandana, I request you to please post our these social media links in the chat box so that our faculty members can follow us on the same.
Yeah, sure. I will.
Yeah. So moving on, next part. This is an industry. So while talking about the industry partners, so as you can see, we have mentioned some of the industry partners on your screen. But basically, I'm very happy to share with you that we have been collaborated with the 450 industries so far. So, and we are very fortunate to collaborate with industry leaders like Infosys, IBM, uh, the Deloitte. So we recently got award from Deloitte. Actually, successively we got award from Deloitte 2 times in successive years for fastest 50 award, fastest growing edutech, uh, uh, which ensures to stay at the forefront of the technological developments. So these partnerships not only grant us to access to the valuable resources, but also foster the association and co-creation, which enabling us to provide the innovative solutions. Similarly, while talking about the academic partners, so our academic partnership with the esteemed institutions like IIM Ranchi, Stinbis University, then recently we have collaborated with the GTU, Gujarat Technical University, which has 486 affiliated colleges across Gujarat state. So that was our milestone achievement recently. And I'm very happy to share with you that we have been collaborated near about 1060 plus higher education institutes in Pan India, and it is still counting. That these collaborations keeps us at the forefront of the innovation happening in the education field, offering the students as well as faculties access to the leading minds and resources, sharing the knowledge. And these academic partnerships also create a sense of community, fostering an environment of the learning and growth in education sector. So I again request to Chandana, please provide our EDL email ID with the phone number so that our faculty members can reach out to us for these academic partnerships. So these academic partnerships, let me focus on this. These academic partnerships are non-commercial academic partnerships. So everything is a free under this non-commercial MOU collaboration. Now let me talk about this everyday learning. This is something like you all faculty members and students are interested, because we are consistently launching new training programs. Training programs on recent technologies for students as well as faculty through SDPs and FDPs. So while introducing this everyday learning program, which is very close to your hearts, so what we offer under this EDL free collaboration is application-oriented learning sessions on trending technologies led by industry experts. And these sessions aim to provide a relevant training and hands-on experience and assist the colleges in meeting the accreditation standards such as NAC and NBA. As I said, that our training programs for students and faculties conducted by industry experts focus on delivering valuable insights and practical skills. At the same time, we ensure the interactive session with the assignments and learning materials through our learning management system. So after some time, Chandana will walk you through our LMS dashboard, how to use that the LMS dashboard, how to attend the live session, how to watch the recording, okay, and at the same time, how to record your attendance and feedback. Moving further, so this is what we are offering under this free MOU collaborations. So again, I request to all the faculty members who are present here, please reach out to us for this non-commercial MOU collaboration, so that your students and faculties can avail these training programs for free. So this is basically the entire bundle you can see on your screen that we are offering under this non-commercial MOU. So industry MOU. So yes, you are collaborating with the industry, EdTech industry, so that we can fill the gap between industry campus and college campus. Then industry webinars. So consistently we are delivering webinars in collaboration with the colleges. So far we have been, we have been conducted 100 plus webinars, throughout this 1.5 year, where 1 lakh plus participant get benefited. And industry FDPs. So yes, today you are a part of this FDP program. So this way we are continuously organizing faculty development programs for our faculties so that they can upskill their knowledge on the recent trending technologies. And yes, LMS access. So we are offering this LMS access for free, and it is for lifetime, so that you can attend uh, the live sessions, as well as you can avail the recordings also. And as I said, that professional training. So through these SDPs and FDPs, we are consistently focusing on the quality of training. That's what uh, uh, we are. I mean, our trainers are industry professionals. They are data scientists. They are data analysts. They are web developers. They are software engineers. They are working professionals who are delivering the training. That's why we called it as a professional training. And as I said, that assignments. So we are providing the assessment on that particular training program on your dashboard. And projects and internship, then placement preparations. So this is all about the student. I mean, this is all about student related. So after your college get connected with this non-commercial MOU collaboration, we will explore these projects and internship and placement preparation part in detail. So in conclusion, XLR is not just a training and consulting company. It's a partner in your educational and professional journey. So that's all from my end. Thank you for joining us, and we look forward to a productive and rewarding few days together. Yeah. Now I would like to request Miss Akanksha to introduce our today's trainer.
Yeah.
Over to you.
Thank you so much, Irfan, for such a warm welcome of XLR. Very good afternoon to all the faculty members here. Today our trainer is Vikas Narune. He is a corporate trainer with data science experience of over 10 years. He is specialized in Google, cloud, big data, and machine learning fundamentals. He has successfully completed training with more than 2,000 candidates globally across diverse data science curriculums. He possesses expertise as a quality management system internal auditor, and currently he is serving as a data science trainer at a prestigious multinational corporation company. So we are thrilled to have him here with us today. So a very, very warm welcome, Vikas. And now I would like to request Chandana, our LMS administrator, to explain you about our learning management system. Over to you, Chandana. Thank you so
Yeah.
much, everyone.
Thank you, Akanksha. Thank you so much. Yeah, good afternoon, everyone, and warm welcome to our 10 hours National Faculty Development Program on NLP, Computer Vision, and Artificial Intelligence. Before sharing my screen, I would like to confirm that all are done with your registrations. If you didn't done with your registrations, I will share the registration link after the KT. So please register that. So let me share my screen first. Yeah, I hope my screen is visible. Can you confirm me?
Yes,
Yes, it is
yes,
visible.
Chandana, it is visible.
Yeah, thank you. So LMS. LMS is a learning management system, and it's a e-learning portal for the XLR and users of the LMS. So in this LMS, we'll get all the recordings and materials, Zoom link, YouTube link, all the things. Okay. And after registration, you will get a mail, verification mail. You can see here. Here we have a verification mail and verification link as well. So click on this link. So it will take you to the set your password page. So we have here password and confirm password. As your wish, you can mention your password and confirm your password and click on my setup password. After that, you will get another mail as well, course invitation for the particular program. We register for the National Faculty Development Program on NLP, Computer Vision and AI. So here we have a registration link, that onlinelearning.xlr.com. So click on this link, it will take you to the sign in page. So here we can see the sign in. So click on the sign in, it will take you to the login page. Here we have a mail ID and password. So whatever you registered with that email ID, please mention your email ID here and password, which you said before. So click on a login. So it will take you to the LMS dashboard. So from here, I would like to explain in a live. So give me a second. So I will reshare my screen and I will go through the live LMS. Okay. So I hope my screen is visible. Yeah, this is our live LMS dashboard. So here we have a two ways to join the session. One is Zoom and another one is YouTube. So I would like to explain about Zoom first. Here you can see National Faculty Development Program on NLP, Computer Vision and AI. So exactly 250, you can see here join button. So click on the join button to go through the Zoom class. If you have a technical glitch with Zoom class, here we have a YouTube banner as well. If you click on this banner, it will take you to the YouTube live. Okay. And coming to the registration, like here we have a National Faculty Development, NLP and Computer Vision and AI. Here we have this tab. I register for this a program. So I'm having this. I will click on this tab. So it will take you to this page. So here we have a curriculum tab. Under this curriculum tab, we have a three sub tabs: feedback response, session recordings, and materials. First, I would like to explain about feedback response. Why feedback response is important? Yes, 60% attendance is mandatory for the participation certificate, and you can give suggestions or compliments on the session, how it's going on. Is there any suggestions? Is there any improvement, like network issue? Like you can give any suggestions also on that. Okay, and one more thing, you have to mark your attendance between 4:30 to 5:30. We will give access between this timing only, 4:30 to 5:30. I'm repeating again. So please make sure and mark your attendance daily. So we are going to send the attendance link daily. Don't miss it because it is mandatory for the participation certificate. And here we have a session recordings. Daily, whatever happened, sessions, recordings we will get here. If you miss the session also, no issue, don't worry. You can see here for the learning purpose in the future as well, because we have a lifetime access for the LMS, right? Yeah, and materials. Yes, whatever PPTs notes shared by the trainer will upload here, so we can refer from here. Yes, this is all about LMS, Katie. So if you have any queries, questions, please let me know in the chat box. At the last 5 minutes, I will take it up and I will answer the questions. Okay. And thank you. Over to Vikas.
Yeah, thank you, Chandana. Thank you, everyone. First of all, Chandana, just confirm that I am audible and let me share my screen so you can confirm at once.
Yeah. Yeah, Vikas, you are audible and your screen also visible.
Okay. So, hello, everyone. Good afternoon. And I welcome all to this series of the AI, computer vision and NLP. So I still remember the earlier session where we started intensively with the starting understanding of the machine learning. And we were able to cover all the basic machine learning concept and algorithms and all. And we also saw the entire code walkthrough. So guys, in going forward with continuation of this series, first of all, I welcome you all for this series. And for next 5 days, we're gonna be there to understand and discover this entire AI path for the advanced learning, along with the deep learning computer vision techniques and the NLP. So thank you very much, Akansha, Irfan, and entire XLR team and Andhra Pradesh State Skill Development Program for giving me this opportunity. And without wasting much of your time, so let's get started. So let me share the agenda for the entire week, guys. So this is what the agenda is there for the entire week. So we're gonna start again to brush up our skills and our knowledge regarding the AI. So what is entire the AI? What types of AI are there? And where we are fitting into this AI stuff, what this entire series is all about. So we'll try to uncover that. And once we understand that where we are focusing in the entire screen and entire domain, then we'll start understanding again from the basics of the ANN, artificial neural network, how the artificial neural network works upon. Yeah, and then guys, we'll try to move to understanding the architecture of the entire architecture of the neural networks, how the networks perform in the background, what is the mathematics behind it, what is forward propagation, back propagation. And then we'll try to understand how we can implement our own architecture for the entire artificial neural network. So last time I did not get an opportunity to present to you one live use case regarding the structured data. So this time we'll try to cover the structured data. And then we'll try to also cover one kind of a image data and simple image classifier we'll try to build along with one structured data classification for the churn prediction. So the same problem which we have solved using the machine learning, we'll try to solve using the artificial neural network. And then we'll try to understand how beautifully this entire artificial neural network will develop on. So that's why we'll try to focus on customer churn prediction. And then guys, once we are comfortable with the ANN, we'll start with a very advanced topic of the computer vision. What is this entire computer vision and which is currently in the demand. So we'll try to understand what is this computer vision, what are the entire techniques and application in the computer vision, and we'll try to uncover what do you mean by convolution neural network and what is the architecture, how it works, what are the different layers. And then once we are comfortably understand this, and we'll try to move to the latest computer vision model, which is YOLO NAS. We'll try to uncover how the entire YOLO series works upon, what are the benefits, how they entirely able to detect the object, detect the people, detect the videos, track the people. So we'll try to understand the entire architecture and the working behind it, mathematics behind it. And then we'll try to implement this YOLO NAS model for our own data. We'll try to look at the entire working. We'll try to implement this YOLO NAS model for our own use case as well, and we'll try to test it, how this is performing on the video data and the image data. So this is going to be a lot of stuff going forward. And then again, not the last part, but just the beginning. So we'll try to understand if nowadays everyone talking about the chat GPT, entire generative AI technologies. People are more concerned about the entire artificial general intelligence AGI arena, where the entire bots are getting humanoid, and the bots are this entire machine learning bots are, or let it be AI bots machines. They are just trying to act as a human beings. So virtually there is no difference between the intelligence, between the appearances, between the understanding. But the only touch which we have is our biological system. And apart from that, everything is getting copied, and they are trying to get it advanced, right? So we'll try to understand and uncover like what is this generative AI is all about. So we'll start with the NLP domain. What is basic NLP? Then if the time permit, guys, and as per your demand, so we would like to also propose that if the faculty member thinks that we going forward will also require this kind of an entire session around the generative AI. So we can dedicate one session as well. So, but we'll try to understand and uncover the basics of generative AI as well in our last sessions, and we'll try to implement one kind of NLP project, which is called as movie sentiment analysis. So I will make a walkthrough for it, and then in the last, if much of the time permits, I will also cover the recurrent neural network basics, and then we'll try to implement one kind of a project which is called as fake news detection using this recurrent neural network. So guys, I hope you found the entire agenda, fully loaded agenda, useful and very advanced, and hope this is making you exciting sessions, very interesting session going forward. So yeah, Dharam Reddy sir, yeah, welcome once again, and hope to see you throughout the session. And I guess most of the faculty members have already attended the previous session. If not, no worries, guys. We'll try to cover from the basics, and we'll try to start understanding entire things right from the beginning. Okay. So this session going to be a medium advance, and if the time permits and if the opportunity comes in, we'll also try to propose you the next advanced session, maybe possible you guys have to come up with a suggestion, and we try to dedicate one more session around this entire chat GPT generative AI thing, which is very, very latest advanced development. Okay. So guys, please let me know your thoughts, your agendas and everything. Procedures for LMS access will be sent for, yeah, Dharam sir, yes. Chandana will be sending this registration form and everything. Don't worry. Chandana, people are asking, Dharam sir is asking that can you please share the procedure for this LMS access and all. So it will be great if you could share some sort of presentation or some kind of a walkthrough with them throughout the mail ID or some other link. You can share it in our chat box as well. Okay. So guys, welcome once again, and let's get started. Guys, you can simultaneously chat with me. You can ask your questions, queries. You guys know the drill, so no need to tell you again. And please go ahead, try to make it very interacting, and let's try to understand what is this all about. Okay. So let's get started, guys, and please give me kind of a thumbs up, kind of a emojis if you are ready. Everyone is comfortable with the agenda, and we can start then. And simultaneously, guys, don't forget to chat with me. You can speak questions, ask questions. Please let me know if you have any queries, any difficulties, any questions. So I will try to answer them simultaneously. All right. So let's get started then. Before we start, guys, I would like to start our today's session with a beautiful quote. Obviously, I am going to tailor that quote. But prior to that, I would like to share the quote of, thank you, China, for the confirmation. I would like to share the quote by our own legend, supermodel for Indian people, Sundar Pichai. And what Sundar Pichai, CEO of Google, saying is that he's saying that this AI is going to have an entire impact on our life, more profound, okay, more profound on humanity, more than electricity, fire, and the internet. I still remember when the internet was launched first time, and the people went so crazy, and this has changed entire our humanity upside down, right? And then what I can say is now the new next standard or benchmark has been become that for the living nowadays people require not only the food, shelter, food, shelter, and nowadays people not only require food and shelter, and along with that, guys, obviously people will require something called as internet to live, right? Without internet, nowadays it is impossible to live, because all our life is depend on the internet. And if you are dependent on internet nowadays, so after some time, that time will come in upcoming years where people will say we cannot live without food, shelter, and the AI, guys. This is what going to happen. And there is a very, very famous, I don't know, guys, if you have heard of this guy who is called as Alvin Toffler. Alvin Toffler is a guy, he's a futurist, he's a writer, and he's a kind of a management guru, guys. And what he said about the illiterate people of the 21st century, he has made very commentable note over here, and which I could not resist to share with you guys. And I have modified it a bit, okay? I have modified it, and please pardon me if you feel it otherwise, but I'm sure you will be also agreeing with me. So Alvin Toffler says that illiterate of the 21st century will be not be the one who cannot read, write, okay, who cannot read and write, but the one who cannot learn, unlearn, and relearn. Okay. So this is what he said. Then, but I have added this term AI now, guys. So now, guys, going forward, looking at the industry term, looking at the entire topics which are going up, the way industry revolution happening, way the lives are getting impacted by the AI. So I have modified this term, and please mark my words. And this is going to be true in upcoming decade, that the illiterate of the 21st century will not be the one who cannot read or write, but one who cannot understand the AI, who cannot understand the AI, who cannot learn the AI, or who cannot relearn the AI, guys. And mark my word, this is gonna be true with the kind of application, guys, we are having nowadays, chat GPT, generative AI, and the way the entire industries, let it be a retail, let it be a politics. And I have compulsory shared this entire one diagram for your reference, guys, and you can look at it. So you just name the industry, let it be a politics, events management, insurance companies, cyber security, home system, entire civil system, defense system, social networking, agriculture, online shopping, aerospace, entertainment, so gaming, communication, education, transport, banking, everywhere, guys. it's lot list, but I just covered the few. Everywhere AI is present, guys. Nowadays, AI is present, and that makes me to say this, that one who will not be able to learn the AI, he will be called as illiterate. All right. So having this thought, guys, let's get started. Then let's try to understand what is this AI stuff and what we going to cover today. Okay, about the AI. So guys, when we speak about the AI, I no need to explain you guys. You guys are very well aware. So what is AI? And nowadays, even a child can say what is AI. So AI is the effort to make the machine intelligent, right? It is the effort to make the machine intelligence, and we're trying to copy the human functionality, the human intelligence into the systems, into the machines, and that's how it is called as artificial intelligence. But guys, so when we try to understand the artificial intelligence, we need to understand the types of artificial intelligence, and based on the type, we have certain capabilities of the artificial intelligence. And why I have included this site is nowadays entire technology is advancing in terms of the not AI, but also something called as generative AI. Generative AI. And this generative AI is nowadays going to change our entire life. So in order to understand, in order to make the effort to understand what's going on in the industry, so we'll try to understand the AI, and we'll try to understand where this generative AI fits in. Okay, where this generative AI fits in, what are the types and what are the approaches nowadays which are taken by the industry in terms of the AI. So to understand the AI, guys, once what we can say is AI can be a software. So it could be a software like image and face recognition, just like this one. So everyone nowadays using the smartphone, and this smartphone gets unlocked the moment I try to hold it in front of my face. So this kind of application, this kind of a software, or you can simply take the example that I'm giving the voice command and it is trying to type a message for me, or it is calling on behalf of me by using the speech recognition, right? Or facial recognition, speech recognition, or kind of a virtual assistant nowadays. We can say that kind of a software, guys. That's kind of a software nowadays is a AI-enabled software. And then when I talk about the embodiment, all right, embodiment means something called as hardwares. The hardwares means actual hardwares where we can touch, we can feel, and we can use this kind of objects. These objects are nowadays become smart using the AI in the background, AI technology in the background, or we can name the few example like the drones, the IoT-enabled devices, smart watches, smartphones, AI-enabled phones, or let it be a bots, humanoid bots, or let it be autonomous cars. All these kind of a capabilities nowadays, we can call them as a AI embodiments, all right? So I think everyone agrees to me what is AI as a software, what is AI as an embodiment. Guys, if you have any questions, any doubts, please let me know. We can chat with me. I'll try to take some question in between. And whosoever want to ask anything, please feel free. You can chat with me in the chat box and I will try to simultaneously answer them. All right. So guys, once we are able to understand what is AI as a software, AI as the embodiment is present. So I would like you to focus out here, understand the capability of the AI, guys. Or based on the capabilities, we'll try to bifurcate the artificial intelligence into such certain categories. And I will come up with the three categories, guys. Three categories. One category we can say is a weak artificial intelligence, weak AI. I will simply call it as a weak AI, sorry. And then guys, there is something called as, which was few days was called as impossible, now which has become possible, AGI. All right, AGI term is nowadays become next normal, and I will explain you meanwhile what is this AGI. AGI is nothing called as general artificial intelligence. Okay, there is something called as weak AI, something called as AGI, artificial general intelligence or general artificial intelligence. And then guys, we have third category, which is called as super artificial intelligence, super artificial intelligence. So let's try to understand. So what are these techniques are and what are these approaches are all about. Okay. So let's take the example and let's try to understand and then try to relate with these three kind of capabilities with us. All right. So when I talk about weak AI, guys, it is also called as narrow AI actually. In narrow AI, what happening is this AI technology is present. Yes, we are using AI algorithm. We are using AI machine learning capabilities. We are using the deep learning capabilities. We are using the NLP capabilities. Yes, we are using, but those are limited to certain tasks, specific tasks. All right. Those are specific to certain tasks and they have the ability to think and make the decisions just like the human being, but they can perform the limited set of responsibilities, So what could be the example here? Okay, what could be the example? Example is, guys, everyone is using iPhone nowadays. In iPhone, we have something called as Siri. So the moment I call Siri, and Siri will get activated and he will start understanding the voice commands. and maybe some kind of a gesture command, and he will be able to perform the task. Let it be a calling someone, let it be a sending a message, let it be a typing an email, right? So he will be able to perform the things. So that kind of a capability. But if you try to say Apple Siri, hey, I am not able to recall when is my marriage anniversary, right? So this used to happen when you get married and you get old. So you tend to forget your marriage anniversary. If I say Siri, when is my marriage anniversary? It will not be able to find out, right? It will not be able to relate what you are talking about, but it will be able to understand if you say, hey Siri, can you call Amar, or hey Siri, can you please call Akansha and tell her that I will be available on the call, right? So this kind of a capabilities, it will be able to understand because it is trained on it. It is able to understand, it is able to mimic the human brain. It is trying to mimic the human capabilities of the decision making, but up to certain constraint, or let it be you call this as a kind of a supercomputer, just like the IBM Watson has built up. This has a limited capabilities. Whatever that task you guys are training, it will be able to perform that perfectly fine or better than human beings. Okay, better than human beings. Even the human beings can make a mistake, but machines won't make a mistake, right? So that's how it is called as weak, narrow intelligence. Then, guys, something very interesting out here is called as general artificial intelligence. Okay, general artificial intelligence. Now, what is happening? See, it is a next level now. Now, what machines have decided that why can't we compete with the humans? And that's how people have made an effort to make the machine just as a comparable or as far as humans. As far as humans means just like the human being. So they are able to analyze the situation, they were able to understand the things, and they are making the capability, thinking, decision making just like the human beings. Just like the human beings. And what could be the example now? The greatest example which I can share is self-driving cars. So self-driving cars, guys, if you try to drive a car, which is an autonomous car, and let's imagine if you're trying to drive a car, and guess what? If when the moment you try to put this car on the roads, and you know the Indian roads, so people won't follow any rules. Sometimes they may, yes, we are following the rules, but sometimes may not, right? Possible. So if you are trained your model, okay, as per the weak or narrow intelligence, just to drive your car, whenever there is a green signal, you can drive. Whenever there is a red signal, you can stop. And in between, if you get any obstacle, try to maintain the distance from that obstacle, right? Let it be this kind of a car if you are having, and it is trying to go through the signals. Obviously, it will try to follow the signal. It will try to follow the path rules which you are training upon. It will try to understand the other object. It will try to detect the object, and it will try to maintain the distance. And based on that, it will try to drive using the Google Maps. Let's say it will try to reach you destination. Guess what? But all of sudden, some animal crosses your path. All of a sudden, someone comes into the picture. Yes, it will be able to understand based on the object detection. It will be able to make the decision. But in sometimes something goes wrong. Something goes wrong, and it will require a special intelligence, just like the human being. That it will fail, guys. That it will fail, right? But they are trying to make the decision. It will try to understand the things. But this narrow one will fail because it is not out of its syllabus, right? You can simply say it is out of its syllabus. But this general artificial intelligence, guys, this is an advanced technique, way too advanced, and it has a capability to think like a human being, and that is why they are trying to use it in the self-driving cars. So in self-driving cars, it is able to understand the situation, and guess what? It is able to deal with the situation which is out of its syllabus also, right? So that is how the capability of the Chat GPT applications are here. If you guys understand the Chat GPT, which is based on the large language model, and if you have trained your large language model on certain data, certain tasks. But guys, there is something called as zero shot learning, which talks about the entire scenario when I am asking my large language model, or I am asking my artificial general intelligence model the question, the task which are not it is trained on, which are not in its purview, or not in its domain, and it is not trained upon it. So how we manage, guys? Just like back in the school days and college days, whenever we used to get one question obviously gonna be there which is out of our syllabus, and how you manage to answer a question based on the knowledge which we have learned, based on the chapters I have learned. I'll try to generalize my knowledge and I will try to answer that question. Okay, the same way, guys, same way large language model also trying to generalize their knowledge, generalize whatever the data they have, and based on that they are trying to deal with the unknown situations. They are trying to deal with, and they are trying to think just like the human being, and they are able to deal with the unknown things, unknown capabilities, or unknown things which are not taught to them. Okay, and based on that they are trying to handle these things, and it is called as zero shot learning. And this kind of capabilities which are required, just take the example of Chat GPT application. So if you are asking the chat GPT application, hey, can you write me a presentation because today I got a artificial intelligence series presentation. Can you write me a presentation? The moment you try to speak like this, and it will be able to come up with the entire bullet points, entire situation, entire application. It will go over the entire Wikipedia, internet, whatever things is taught upon, and it will try to pull up all the information and it will try to give you a thing, right? So that kind of application we are talking about. Or let's take the example, guys. Now, artificial general intelligence talks about ROS, guys. ROS are called as AI attorney. Nowadays, guys, if you try to don't get surprised tomorrow, if you try to break any rule, or let's give a small rule, just like the breaking the signal, and what usually happens is we get a challan. And what you have to do is we have to go to a court and we have to present in front of this. This used to be the old days. Nowadays, everything is online. Let it be a thing, but try to understand the situation in this way. Let's imagine that you break some small rule, and now you are facing a repercussion for it, and now you get such challan. So breaking the rule, right? And once you break the rule, guys, don't get surprised that tomorrow you will be getting one Zoom link, and within that Zoom link you have to log in. And where we log in, you will be able to understand the bot, humanoid bot, who will be talking to you, who will be acting as a judge or a kind of a attorney out here, and who will be able to understand and able to tell you, okay, so this kind of a situation you have faced, and this time at this moment you have broken a law, and as per the Indian Penal Code, this is the repercussion for it. And as per the law, these are the charges, and you have to pay these charges. Do you agree? So you'll say, yes, I agree. You are participating in that meeting through the Zoom link via phone or via smart devices. And yes, you agree. And the moment you agree, guys, you will get a request to your API, UPI, sorry, and you will be able to get paid with the entire charges, and you will get a clean sheet out of it, right? And so you'll be able to walk away with that entire situation and entire case, right? So guess what? This kind of a capabilities where, just excuse me, guys. This kind of a capabilities, guys, this kind of a capabilities where we require intelligence, but just like the human being, right? We are trying to analyze the situation, whether this person has broken a law or not, whether that resembles to our entire Indian Penal Code. And as per that, understanding the matching, the pattern, understanding the rule and requisitions, and then trying to pass the judgment. Okay, this kind of a capabilities, guys. And there is really this kind of a situation where they have developed a robot called as Ross, who is working as a AI attorney, guys. Okay, so this kind of a things is called as general artificial intelligence, guys. And let it be application like chat GPT, or let's take the example of the Harvard AI professor, or can be a Sophia, Amica, this kind of a humanoid robot. Okay, all these example of general artificial intelligence who are trained just like the human being. They have a capabilities like the human being. And don't get surprised that tomorrow if we get replaced by I am a professor, and tomorrow I will get replaced by something called as AI professor, right? Who will be able to understand you, you will be able to teach with you, or he will be able to take care of the entire situation, right? So that kind of a capability, which was impossible 5 or 10 years back, is now possible when the OpenAI launched this kind of application, which is Chat GPT. When people introduce the humanoid robot, or kind of a AI professor, kind of a legal attorney, Ross, self-driving car, Sophia, Amica. Amica is engineering drawing robot, which is a humanoid robot which can understand the entire drawing, entire art. Okay, that kind of a capabilities we are talking about, guys, which is way advanced, and that is called as general artificial intelligence, AGI. We are now living in the era of AGI, which was said that it is impossible to achieve this AGI till 2040 or 2050. Okay, so I guess now enough of this explanation. What is this general AI, general artificial AI? Everyone is able to relate now what it is. Then, guys, there is a third capability which is called as super artificial intelligence, and which is yet to receive. We are yet to achieve this kind of things, but I am sure in coming 20 years, we'll be able to understand this kind of a capability. I am sure, guys, just if you want to understand what is super artificial intelligence, you need to understand that the intelligence or the AI, which can surpass the human being, in kind of analytical decision, in kind of a capabilities, cognitive features, or reasoning, thing, puzzle solving, assignment, or let it be any task related to cognitive energy, related to the vision, related to the decision making, to the intelligence. It will be better than us. It will be better than the human beings, right? Entire human races. That is called as super artificial intelligence. And what is the example, guys? I am sure everyone must have watched the movie, which is called as Terminator movie by Arnold, famous Hollywood guy. And in that Terminator movie, guys, if you are able to understand, or if you have seen that movie, there are the machines which think that they can rule the entire domain, entire Earth with their entire own dominance. And that's how they decided to make the humans as their pet, and that was called as Skynet. This Skynet was so powerful that it can gauge the entire human being. It is trying to surpass the human being, and they're trying to rule the entire universe, right? So that is what was shown. It was science fiction, but people guess that in upcoming years it could be also possible, guys, right? Or let's take the example of the Jarvis Iron Man. Everyone has seen the Iron Man movie. In that, there is Iron Man, this guy Robert Downey Jr., he always tried to speak to a certain kind of a virtual assistant, right? Jarvis, right? So this Jarvis is nothing but kind of a super artificial intelligence example. When you try to talk to Jarvis, and Jarvis is able to perform all the impossible tasks just like the human being, right? So he asked the Jarvis what could be the example, and he tried to stretch his hand like this one, and he will be able to get a 3D architecture, right? And then in the 3D architecture, he can rotate, he can understand, he can create an entire new application out of it in the 3D dimension, 5D dimension, okay? Or let it be a kind of a capabilities where he's asking Jarvis, can you please load my missile, load my suit, or within the one voice action command, it will be able to perform a task, right? Or let it be a Iron Man suit, which is able to make him fly like just like the superheroes, right? So that kind of a capabilities, guys, will be called as super artificial intelligence, and it is yet to receive. It is not happened, but in upcoming up to 2050 or 2060, it could be possible that we will try to experience this kind of a capability, right? So, all right, guys, I think everyone is able to now understand and able to relate what is the artificial intelligence capabilities we exist and where we are trying to understand these things. Now, coming back to certain trend, industry trend, and where we are headed today, and where this artificial intelligence has reached. So, I have put in this slide, guys, for you, and to understand that what we going to understand or where we are trying to move forward in terms of the technology. So, guys, let's try to understand from the beginning, and we'll try to relate our today's session. So what part of the session we are trying to focus today? Okay. So if I try to talk about the artificial intelligence, which is the entire thing which revolves around making the machines as intelligent as the human being, or trying to mimic or copy the entire human functionality, human brain functionality, cognitive functionality. That is the entire AI that you can call this as a universe. All right. You can call this as a universe. In the part of the universe, we have learned something called as machine learning, guys. So in our last series, we tried to dedicate this series to the machine learning capabilities. And then when we try to talk about the machine learning, guys, it is a part of AI, but it is try to focus mostly on the structured data. On the structured data, and no need to ask what is structured data. Structured data is something which can be footed into a rows and columns data. That kind of a data it is trying to use, and it is using something called as y equal to mx plus c. This kind of a statistical algorithm based on the distance calculation. Based on the distance calculation, it is able to perform the things, and that kind of a capabilities is called as machine learning now. All right. So once we talk about the machine learning, it is a part of artificial intelligence. And then, guys, our entire session, we're trying to focus on the deep learning capabilities. And then we talk about the deep learning. It is a part of machine learning, which is a part of AI. But deep learning, you're trying to use something called as the neural networks. Neural networks, which we'll try to understand how they're trying to mimic the entire brain functionality, entire human biological neural system, HBN. This is what they're trying to mimic, and they're trying to build something called as artificial neural network, ANNs. Okay, and this is what we are trying to use, and we try to understand in the deep learning technology. And in deep learning, we are trying to mostly deal with the unstructured data. Unstructured data, which is something called as image data, let it be a video data, let it be a audio data, let it be a text data, let it be a sequential data, which is not able to handled by the machine learning capabilities, right? When this is a huge amount of the data nowadays, if you try to understand, guys, entire data which is produced in the entire domain, entire today's world, 80% of the data is unstructured. 80% data is unstructured, because nowadays everyone is using smartwatches, smartphones, smartphone capabilities. Everyone is trying to interact using the Facebook, Twitter, digital application. Entire digitalization has been happening across all the industries, and this is generating in terms the entire data, right? So entire 80% of my data, which is generated out of 100% data every day, guys, it is unstructured. 80% data is unstructured. Let it be images, let it be a voice, let it be a text data, let it be any kind of emojis, thumbs up, application, whatever you guys are doing nowadays, everything 80% of it comes to unstructured data. And that is why we are able to understand that deep learning is now gaining the experience, or deep learning is now gaining the popularity nowadays, guys. And then when I'm trying to talk about the artificial general intelligence, guys, AGI arena, AGI capabilities. Now this AGI capability is also called as generative capability, generative AI capability, right? So what do you mean by generative AI, and how it is different for the narrow AI or normal AI? Guys, let's try to understand. If I'm trying, and when I spoke about the deep learning technology, guys, deep learning uses the artificial neural network, or let it be a convolution neural network, or let it be a recurrent neural network. All kind of a neural networks which are used by the deep learning technology to solve the business cases. And that is what is called as deep learning nowadays, which is also a subdivision of the entire machine learning AI, guys. Now, narrow AI, when I talk about narrow AI, is the amalgamation of the deep learning machine learning technique. And but when I start to talk about the latest trend, which is like the chat GPT kind of application, right? Where on the voice command, people are generating the entire images, videos, video recognition, video generation. Or we have also seen the negative example or the unethical example, which is specially talks about the deep fake, guys. Deep fake, right? Recently, we have seen the news that the daughter of Sachin Tendulkar, Sara Tendulkar, she filed a case and complained about this deep fake, and she was a victim of this entire deep fake technology and misuse of it. And I am sure that you guys have heard of it, where there was a photo shared by her on the Instagram with her brother, and which was the birthday of that guy, and with her brother, she posted that picture, and people use that picture as a base picture, and they generated a fake image out of it, which is called as a deep fake technology, which is a part of the generative AI, guys. People are actually making the misuse of it. That's why we have to understand the certain ethical concerns around it as well, right? When we try to implement the AI. So, guys, it is very, very important, and that's how nowadays, even if you guys are now able to understand the things, that European Union has passed the laws against the AI, that what could be the AI, what kind of a capabilities it should have, and what kind of ethics should be present, and what will be the repercussion if the AI try to break the privacy of the things, right? So European Union passed the law, guys, around the AI, and also the United States is passing the law around the AI. Now is the time for the India also, since from beginning of this deepfake technology and people were victim, the India is also now planning to put some kind of a guidelines around the AI, right? About the ethical uses, about the repercussions, about the penalties, about the legality of the things, right? So this is what the things are all about. And let's try to understand, when I talk about the generative AI, what is generative AI and what is its part of what, right? So generative AI means what? In normal AI, technology or normal narrow AI technology, it is first thing that it is trained on the specific task, and it is trying to compare with the human being. But guys, generative AI is a subset of AI which is trying to learn from the data, and it is able to generate something. If you try to give an input, it will try to give a data, it will try to use that data, and the generative AI will try to generate something out of that data, right? Just not like that classification is happening, some kind of a word prediction is happening. No, that's not is called as generative AI. Generative AI, guys, it is using something called as large language model, which are trained on the huge data set. Like, let's imagine this way, that this generative AI technologies, when we try to talk about the Gen AI, so Gen AI capabilities or large language model capabilities, they are trained. Let's imagine if you try to take the entire Wikipedia and you try to train your model on the Wikipedia, right? So that kind of a capabilities will be called as large language model. Where, let's imagine if in your entire college, guys, if there is a library available, out of that library, all the books, you are trying to take all the books, and you are trying to train your model on the all the books which are available for the disposable, right? And that model, that kind of a model is called as large language model, guys. And this large language model, they mostly using the architecture which is called as GPT kind of application, which is called as generative pre-trained transformer, which is a part of the recurrent neural network, or something called as generative adversarial neural network, GAN model, which are also similar to the CNN and the RNN capabilities, convolution neural network technology. So when I'm trying to understand the Gen AI, everything lies with the basics. So we are going to focus on the basics, guys, RNN and CNN and ANN. And once we understand these capabilities, guys, then we will be able to understand what is the generative AI. The generative AI means, simply I would like to tell you that if I am trying to provide data, let's take the example that I am providing some music data. If I am providing this kind of a 10 minutes of audio clip, okay, 10 minutes of audio clip to my artificial neural network. So what it will be able to perform with that music of a 10 minutes audio clip? So it will be able to bifurcate. It will try to perform something called as discriminative AI or discriminative AI, which is called as, if I pass a music, and I will be able to use the artificial neural network, and it will be able to give me the result, whatever that music was there, whether that music belongs to a classical, belong to a rock music, or belong to a jazz music. Okay, so that kind of a discrimination it is able to perform. But the same example, if I try to provide a 10 minutes music to my generative AI capability, okay, to my Gen AI kind of a capability of the AI, And then what it will be able to perform with this music, 10 minutes of audio clip. If I try to forward to a Gen AI, it will be able to create an entire new music, a new genre of the music out of that entire 10 minutes of audio, right? So that capability of generation of the music, generation of the images, generation of the videos, generation of the pictures, or little bit generation of the kind of a short films, or generation of the text, or generation of some kind of a other capabilities where we require a special intelligence, just like the human being. That kind of a capabilities is generative AI. All right. So in generative AI, if I say that if I pass any data, and out of that data, if I am able to generate the new data, which could be a image, which could be a text, which could be a video, which could be a audio. Okay, so that kind of a capabilities, guys, will be called as generative AI, because it is trying to generate by using, or by trying to understand the general capabilities or about the general data. It is trying to generate the new thing out of it, and when we are just simply passing the things, and it is able to perform the classification, it will try to perform the identification, or it is able to perform the tracking. That is called as discriminative AI. So I guess everyone is able to understand what is Gen AI. And if you want to learn or become the expert, which is the current industry trend of the artificial general intelligence, you need to learn something called as now deep learning, right? The focus is more in the deep learning, and this is what our series will be doing today. Today we'll try to understand the artificial neural network, then we'll try to focus on the convolution neural network, and then we'll try to focus something around the recurrent neural network and the NLP domain nodes. All right. So I think now this slide is very clear, and everyone is able to understand the capabilities, able to understand generative AI. What is generative AI? What kind of a large language model exists? What is called as generative pre-trained transformer, or generative adversarial neural networks, GAN networks. These are the base for the application, just like the Chat GPT. Chat GPT is not the one, guys. There are something called as DALL-E. There is something called as Palm model. There is Falcon model. There are a lot of models. Okay, LLMA model is there, Palm is there, Falcon is there. So many much more models are there. Let it be a midway, runway, all this kind of image generation, text generation, picture generation technology. So that kind of a capabilities now are a part of generative AI, and that is what the people are focusing nowadays. So all right. So guys, any questions, any doubt until now? If you feel like you want to ask anything, any queries, please address me in the chat box. I'll try to take it simultaneously. All right. So once we are able to understand, guys, let's start our discussion to understand the AI now. So what is called as artificial neural network then? Guys, please give me confirmation if you are comfortable till now. If you don't have any doubts, any questions, give me kind of a confirmation, give me kind of a thumbs up, and we can go ahead then, guys. Or if you have any doubts, any questions, please let me know, so we can address them as of now, and then we can start our discussion. Abdul, okay, thank you, guys. All right. How can create an AI for the institution? Gauge. Prakash Kumar sir, can you please elaborate your question? I will answer them. How to create AI for the institution means what kind of a use case? Do you have any use case in mind? Like use case, I am not able to understand like what you are asking. Can you please be specific, sir? Please try to throw more light. Education institutions. Yeah. Education institute, there are a lot of use cases, sir. Just like take the example, like if you want to perform kind of application where you want to understand the entire human beings or your entire students sentiment analysis, like what is their sentiment regarding the courses, what is their entire sentiment about the professors, that kind of a things. Let it be NLP domain, let it be a sentiment domain, or a lot of use cases possible. If you have anything in your mind, any special use case, please let me know. Otherwise, I'll try to suggest few of the use cases for the education institution. Okay. So I hope I am able to understand, able to give you a question answer, sir. Okay, guys. Thank you, Abhaya Sau, sir. Thank you. So, guys, let's try to understand. And guys, please, meanwhile, please let me know. Just like the thanks for asking, sir. Thank you for confirmation, guys. And Prakash, sir, please come up with some example or some specific use case if you have any mind. And I'll try to give you also from my side some suggestion or some ideas. All right. So guys, before we try to understand, before we try to uncover what we mean by. Yeah, awesome, sir. Awesome. Prakash, sir. Yes, we can have. I will try to explain you this kind of thing. If we give a image, then related to display info. Yeah, yes. Few example of AI in health domain. Example scan report. Yes, yes, Dharam, sir. Yes. We can take this example. I will try to provide also if possible. That kind of a use cases also I'll try to provide. Yes, sir. That is also possible. Like if you try to give an image and it will be able to give you information about it. Yes, completely possible. We'll try to take anyhow. We are going to cover this convolution neural network in upcoming days, like tomorrow and day after tomorrow as well. So once I try to explain you that model, guys, YOLO model, so you can use that entire YOLO model for solving your use case, like scanning the reports and all. Yes, possible, entirely possible. Or for the image data, you scan the image and it will be able to display the information. Guess what? Like you scan the image, it will be able to detect the person over the Wikipedia, over the Instagram, Facebook, everything could be possible. Okay. Yes, yes, guys. I will provide you this. All right, guys. Thanks for asking. And let's get started then, guys. So, guys, we'll try to understand what do you mean by artificial neural network and how the artificial neural network works upon. Okay. So, in order to understand the artificial neural network, guys, we'll try to understand the entire human brain functionality, how this human brain works, how the entire human brain functionality works, and how is the entire humanoid biological neural networks works. Okay, we'll try to understand for a couple of minutes and we can relate that things. And I'm sure it could be a good exercise or recap for the guys who are already joined this session. And you can take this as a recap, guys. So let's try to understand what is happening and how can we relate now the entire human brain with the artificial neural networks. All right, Praveen Raj, sir. Okay, recordings will be available. Yes, the recording will be available in the LMS. Otherwise, I will ask my colleague to give you this links. Chandana and Amar, my colleague, can give you this link, and you can refer there, guys. Already, all the recordings are available. Okay, on YouTube as well as this one. Okay, guys. So let's try to understand this one. So when I try to focus on the human brain, what I've tried to do is I'll try to compare the human brain. We'll try to understand about the neural networks and we'll try to compare this neural network, guys, with our artificial neural network. We'll try to understand how they are trying to copy the things. Guys, the main thing when I try to talk about the artificial neural networks, ANN, right? So you can simply say that ANN is nothing but it is an effort. It is an effort made by the humans to copy or to imitate the entire human brain's functionality, okay, cognitive functionality or decision making functionality, or you can say the intelligence, the intelligence part, or the whatever the intelligence part, whatever the cognitive part, whatever the recognition part is there, that capability has been, it is an effort made by the people to copy that functionality or to imitate that functionality in terms of something called as artificial, not exactly a copy or effort to copy the things, just like the biological clone. You can say they're trying to clone the capabilities, okay, simply. So that is called as artificial neural network. So when I try to talk about that, it is trying to clone or it is trying to imitate, is a effort to make a copy of the human brain functionality. Let's try to understand how the human brain works and what are the things that they are available in the human brain and what are the capabilities are there and how the architecture look like. Okay. So guys, let's imagine this is the human brain, and by human brain, once we have a sensory organ, just like the mouth, eye, nose, or touch, or we can hear the thing. And by these things, we getting some kind of an input, right? And once we get the input, guys, that input pass on through our neural networks. And this is what the neural networks we are trying to showcase here about the brain, okay? In the human brain, let's imagine we have something called as our neural networks. And these neural networks are available not only in the human brain, guys, it is available in the entire human body, right? Entire human body, let it be my hand, finger, touch, everything, leg, what entire body part. This let it be take this hairs also. So everywhere this hair also. So everywhere, guys, this kind of a functionality is available, and you can try to uncover that, and you can refer to the biologic book also, and it will try to agree with the same thing. All right. So once we are able to understand that neural network not only present in the human brain, it is also available in the entire body parts, and that is how people are able to make the decision and the actions are taken by the human being. So let's try to understand that this kind of a neurons, okay. So whenever I try to look about this kind of a human brain or this kind of a functionality of the human brain, there is something called a neural network, and this neural network is made up of this kind of a circle, small circles, okay. So this kind of a circles are nothing called as neurons actually. They are the neurons. And when we are trying to build the neurons in terms of the collective efforts, we are trying to build kind of architecture. That architecture is called as neural network actually. Neural network, right? This is what is called as neural network. And what people have done is this neural network has been copied. So they cannot copy the entire thing because they're not able to produce the entire biological copy. So what they have done is they try to copy it through the kind of a virtual functionality, virtual project. And by creating this virtual project, they are trying to fit it into some kind of a equation, which is called as WX plus B. WX plus B. They are trying to model the entire functionality in kind of a statistical functionality, and they are virtually trying to copy the entire functionality the way human brain works. Okay, so this is what is called as artificial neural network. And let's try to understand. Let's try to compare the human brain functionality working, and we'll try to understand the ANN accordingly. Okay. So when I'm trying to understand this guy's human brain, and this human brain, now I talked about the neurons. So these are my neurons. These circles are neuron. What I'm going to do is I'm going to take one neuron and I'm going to zoom it here. So this is the zoomed copy, guys. This is the zoomed copy of the neuron. This one neuron I have taken here and I'm trying to zoom it. And this is what my first picture talks about. Okay. The above part of the picture talks about this entire neuron, how the neuron works upon. And then the below part, bottom part is a part of the ANN, artificial neural network, one neuron, how the one neuron will work. The neuron out here, the neuron, which is the one small biological part of the entire neural network, the circle. Now this circle now is we are trying to copy that circle, and that circle or that kind of a neuron, guys, will be called as perceptron out here. Perceptron when we talk about the artificial neural networks. Okay. So now what we're going to do is we're trying to compare the neurons with the perceptrons, and we're trying to understand simultaneously how the functionality works upon and what are the efforts made by the people to copy the things. Okay. So let's try to understand this one, guys. Okay. So I'm taken one neuron out here and try to zoom in here. And this is what the entire diagram talks about it. Okay. So when I try to zoom in, guys, let's try to understand how the human brain functionality works upon and how the entire decision making has been done in the human brain or in the neural networks. Okay. I'll not specifically say brain, but we'll try to relate it to the brain. Okay. So because brain is our central repository where we try to perform the central processing. Let's imagine this way. So let's try to understand what is this architecture is all about. So let me show you first. So this circle, guys, out here, which is called as cell body. So this is the minute part. And when we try to take the least minute part of the entire neural network, which is called as a cell body. And this cell body has something called a neuron, guys, here, neurons, okay, circle. And that circle is called as nucleus here. So we have learned in biology classes, let it be my head grade subject. I am sure everyone had the pain, everyone has a brain through the pain to understand this biology, anatomy, or zoology. And but we were able to force to learn these things. And now thank God, though the people they're trying to help us to understand or force us to understand the things. Now we can actually relate our biological topics with our artificial neural network because it is a biological copy, but it is an artificial biological copy of the entire human brains working, right? So when I'm trying to talk about the things, I'm sure you guys have heard of the biological term, which is called as nucleus. It is a minute part or center of the entire cell body. And within the nucleus, there is something called as proton, electrons, neutrons, which are revolving. There is an atom here present, which is a core. And through the nucleus and the core, all the things are working. This is what we have learned, right? And let's try to understand the same way, guys. This is called as cell body. This is called as one neuron out here. Within that neuron, there will be something called a nucleus, and this nucleus will be able to perform all the functioning, all the processing of the information, right? And this is called a cell body now. And once this, we have a call as a cell body, which is one neuron where I'm trying to focus here. Guys, we are receiving some information, right? Obviously, what happens is, in general scenario, through our sensory organ, we are receiving some information. And that information is called as signal, guys, signal, okay? So let's call our information input, IP, as our signals now. So what human brain does, okay, let me generalize the things that once we are able to get the information through our sensory brain, that is called as signals. That signal based on their criticality, okay, if the signal is important, then that signal will be fired upon. That signal will be passed upon into the next neuron, into the next level, to the next neuron, and then that's how we processing through the different neuron level, to the different neuron circles, through the neuron layers, and we will be able to perform the things, and we will be able to understand the thing, and we will be able to take the decision accordingly, and then the action will be performed by the human brain. Okay, so this signal will be passed on through the different layers, through the neuron, through the layers or circles, and then after that it will be able to fire the information. Once we decide that whether we can fire the information or not to fire the trigger, we can simply say that there will be trigger will be happening. Some signals will be triggered, some signal will not be triggered. Okay, based on the criticality, based on the information, based on the importance of that information. Okay, this is what will happen, and how we are receiving this signals. that if this is my cell body, this is the nucleus, and this nucleus is receiving information, something called as this kind of lines, which are called as dendroid, guys. Okay, which is nothing called as dendroids. Now my dendroids are now able to pass the information to my nucleus, to my neuron, and within the neuron I have a nucleus which is able to process the information. And what happens inside the neuron, guys, based on the signal means I can say that this dendroid works as an input. This input is passed on to my neurons, and within the neuron means which is the information. Info is same as signal, guys. Signal is same as info. So once the signal is strong, when the importance of the signal is very much, the weightage is more, that the particular neuron will, guys, it will try to glow it. Means there will be a firing happening. So it will try to fire the information. It is if it's important information. That's how, if you try to look at some of the examples or some of the pictures where people are trying to showcase, if you get at 4 p.m. or 4 a.m. in the morning and in the midnight, what is happening, how your brain look like, and some of the things will be glowing and some of the things are not glowing. Okay, some are pale, some are bright. So what does that mean? Okay, what does that mean? Means all of your neurons are active or all of your neurons are not active at certain moment or certain point of a time. That's what they're trying to talk about. That active means they are trying to perform certain things. They're trying to perform some operations. Okay, this is what is happening out here. And when the information is signal is fired, when information is processed, and when the information is important, guys, this neuron will try to glow this way. It will be a spark of electricity will be happening. A spark of electricity will be happening, and through which it will be able to pass the information to the next layer, to the next neuron, or to the next level. This is what is going to happen. So we pass the information to the dendroids, the nucleus cell body, which will be able to perform the information. It will be able to give weightages. It will try to weight the information. Once that signal information is important, it will be passed on to the next layer. There will be a sudden spark happening, and that's how the moment within the fraction of second, all my neuron will start glowing with the colors. Okay, and this is how the information will be passed on. And when the information is passed on, guys, that information will be passed through the something called as axons, which are this kind of a lines, and these lines will try to get splitted, and it will try to bifurcate that information to the entire body parts of the human being. Okay, and this is how the information is carried out from the human brain, from one sensory organ, from the human brain. From human brain, processing happens, and the entire information is carried out to the different body parts. And based on the information, based on the knowledge, the action performance will be done. Action and performance will be done by the human beings, right? This is what, not only human beings, all the living beings. This is what will happen if the neural networks are there, right? So this kind of a thing we have understood now. Let's try to understand then. Then when I try to talk about this biological neuron, guys, what I have understood are there are three important parts. Now there are three important parts. First part is something called as dendroid. Second part is something called as neurons, a nucleus, and third part is called as axons now. So this dendroid works as an input. Then this becomes my processing power, processing unit, nucleus, cell body, and then axons become my output, which are able to carry my output, right? This is called as something called as three-tier architecture. Three-tier architecture of the entire human brain, right? Human brain neural system. So then, guys, once we are now able to understand this is what happens, and this is how the information flow is created. Then like to compare now. Now what I've done is, now I have taken one neuron out here and also try to stretch it here, and we are trying to understand that what kind of capabilities has been done and how the entire ANN works. Okay, and how we are trying to copy these neurons out here, which is called as perceptron. So guys, what happens is in 1940s, okay, in 1940s, somewhere around that point of time, okay. So let me tell you the exact name of the gentlemen and exact thing of who were the gentlemen. Okay, guys, in 1943, okay. So to be very precise, in 1943, there were the gentlemen which is called as Mackellar and Pitts, guys. These mathematicians, they brought one model which is called as single neuron model of a neuron, or you can call as a single perceptron model. Single perceptron, because the neurons are called as perceptron when we try to copy them. Okay, so what happened is, I am trying to take the same copy of that one single circle. Okay, that single circle is out here. This is what the single circle we are talking about. Now we are trying to compare this single circle out here, and we try to understand. I have just zoomed in here, and this is the cell, and this gentleman, statistician Mackellar and Pitts, they are the first one. They have made efforts to copy this functionality. Okay, and what they did, try to understand, they created something called as a model of a neuron, or single neuron model. Okay, what they have done. Now try to understand. So in the human brains, we have something called as dendroids now. something called as dendrites, and dendrites is able to pass the information. And then we have something called as nucleus, body parts or neuron, and that is able to perform the part. In the core, we have a nucleus and celly body, and it is able to perform the processing. And we are getting our axons through which we are passing our information, right? So similar way, guys, what they have done is they are trying to create one single neuron. So when the first time they try to create an entire copy, guys, what they have done, they were able to create only one single neuron. That single neuron was called as perceptron. One single thing they have taken, one single object, and let's try to understand what they have done, what kind of capabilities they have done. So what they decided is that I will try to pass some kind of a signals here. So signals will be called as x1, x2, x3. And what are the signals? Signals are nothing but my input, kind of a data, kind of a information I am passing here. Okay. So I am passing these inputs, which are called as my signals now. But what's going to happen is when I'm trying to pass the signal, guys, I am also trying to pass certain kind of a weightages to it. Okay. Certain kind of a weightages. So what is happening is I am passing one signal, one information x1. I am trying to multiply back that one weightage called as w1. Then when trying to pass the second input, second information, second signal, I am trying to copy with the different weightages w2 and so on. Whatever information I will pass up to xn, I will try to multiply with the different weightages wn. Okay. So this is what going to happen now. So I can write this and wi, which is stands for something called as weightages, all the individual weightages. That weightages is I equal to 1 to n possible. And then I am passing something called as x. I will write as a capital X. The capital X stands for the input or the signals. I am writing xi because I can stand from 1 to n. This is what is happening. So this is what is happening is they are passing the signal and they are applying to the weightages. And once I apply to the weightages, guys, what is going to happen is I am trying to perform a summation of this. You can say the summation sign, and that summation sign will be called as h, a kind of a function. It is kind of a function, simple function. H, I am calling that as h. So what h is doing is it trying to multiply the weightages into the different input signals and trying to sum them up. That is called as h, guys. And that h will be passed on to my neuron now. That h will be passed on to the neuron, and based on certain decision making, based on certain kind of activation, based on the activation, whether it will be able to activate that information, means able to fire the information or not to fire the information. This is what the exactly thing it did, and it was not able to learn anything. It was not able to do anything. It was just able to collect the signal, collect the weightages, and it is able to pass on to this here. And out of that, it will be able to pass the information. It will not able to pass the information. 1 means pass, 0 means not pass. Okay. Either it can pass 1, it can fire the signal, or it can not fire the signal. And this is what the copy they tried. And at that time, they were not that successful. So this was the single neuron model which they developed. And this was the first copy, exact copy, which was made effort in 1942 by the gentleman McElon Pitts, guys. Okay. And this is how they also tried to copy something called as dendroids. Just like the dendroid, we have something called as this input information weights. And then we are able to pass that, applying the weightages, and then we'll be able to process into something called a nucleus, which is our neuron hidden layer, which we'll try to explain here. And then we will be able to fire or not to fire the information. Okay. This is what has happened, and they completely failed at that time. They understood that the single neuron model will not work anything. It will not a good model. So there will be nothing can be achieved. It will be able to just collect the information, pass the information. That's it. Whether it pass or not. Okay. Okay, guys. Yes. My colleague Chandana will share the attendance. Don't worry, guys. In the chat box in a couple of minutes. Okay. Then, guys, once we are able to understand that this entire model has failed, so McElon Pitts, guys, what they did is they tried to understand that single neuron will not be helpful. Single neuron will not be helpful if I want to make the copy, if I want to make the functioning exactly working. So what I can do is I can start understanding if I have a multiple perceptrons, then I can arrange this perceptron this way, one above other. I have to stack the perceptron one above other, but the stacking is not a one single layer. I have to create such multiple layers like this way. So this architecture gave a birth. They gave a birth to something called as multi-layer perceptron. Something called as multi-layer perceptron, guys. Multi-layer perceptron. What is this multi-layer perceptron? Rather than taking this kind of a single perceptron, single neuron, they tried to arrange the different kind of a neurons above each other, and parallelly also they created a layers of such neuron stackings. Okay, and then they were able to come up with this kind of architecture. Now that is how it become a artificial neural network. That is gave to the birth of this concept, which is called as artificial neural network. And I'm sure you guys might have seen this kind of a diagram. Whenever we try to talk about this kind of a diagram, this diagram is called as artificial neural network, ANN. So this is what is called as ANN, which is actually a multi-layer perceptron, where we are trying to arrange the different kind of a different kind of a perceptron above each other. We try stacking them, and such stacking we are taking the different layers, layer number 1, layer number 2, layer number 3, and so on. Okay, so same way guys, they try to create, and same way like we have a 3-tier architecture, the same way human system has the 3-tier architecture, same architecture has been copied, and they try to create it, and it is called as something called as multi-layer perceptron. Okay, so that is the first effort, and this is how the multi-layer perceptron look like guys. And this is what the entire gave birth to this kind of a technology, which is called as artificial neural network. Okay, artificial neural network. And this is the history, guys, how the artificial neural network comes upon. And this also has a 3-tier architecture. Then we have a first architecture or first layer, which is here, which is present out here, which is called as a input layer, IP layer. Okay, IP layer. Then in between you have some layers in between layers, which are able to perform the same task, just like the cell body, just like the nucleus, and which are able to perform the process the information, which are called as hidden layers up to here. And then once we perform the input, which is the dendroid layer, and then we have something called a cell body layer, which is a hidden layer, then we'll be able to get our output, which are axons, which are axon in human body, and this is called as output layer. And through this output layer, we will be able to get our predictions, y hat. Okay, so here we are passing our x1 to n, xn through these different neurons. It will be able to process these neurons here, and then it will be able to give us a predictions out here, y hat. Okay, this is how that they are created successfully later on, and this is created a 3-layer architecture, input layer, hidden layer, and output layer, and it was able to become very, very successful, and it was able to perform the task just like the human brain capabilities. But initially the task was very difficult, and they had to come up with, yes guys, I will try to share the link once again. My colleague has shared it, Chandana. I will share also, Nitin, yeah, to everyone. Right guys, so I've shared just attendance link with everyone. Please go through it, and please try to fill in, please try to mark your attendance. All right, so guys, this is how that they gave a birth, and this model were able to understand. And what happens is they try to understand that this kind of a resources, this kind of a data is real-time data, this kind of information, guys. So this is a very, very important that this kind of a information, this kind of resources, this kind of architecture cannot be processed in the real time without the need for the human intervention, and with the process of the GPU, graphical processing unit. So this graphical processing unit is required to process this kind of a neural network, and this also requires some kind of a human intervention, or without human intervention also it can perform, but you have to perform a labeling or unlabeled data, and then on basis of that you have to perform the training, and without that, then without the human intervention, they can process the information simultaneously. A lot of information can be processed, could be a GB, petabyte, zettabyte of the data, and they will be able to give you a desired result, which is called as y-hat your prediction. Okay, so this is what the entire artificial neural network works upon, and this is what the idea is all about the neural networks, guys. This is called as popularly ANN, artificial neural networks. So once we now understood what is ANN, guys, let's try to uncover, let's try to understand how the entire architecture works upon, how the input layer works, how the hidden layer works, how the output layer works, and what are the operations which are performed, and through which they are able to understand that whatever signals, whatever information I am receiving, which information or which signal to fire and which not to fire. How it will be able to take the decision, how it will be able to understand that which information has to be passed on, which information has not to be passed on. All these things we'll try to understand now, guys. All right. So let's try to deep dive into this one. Okay. So what is going to happen, and what are the steps happening out here? Okay. So let's try to understand this small architecture, small things, and guys, I will try to understand and make you understand. So what is going to happen out here? Okay. So what is happening? Let's take example. I will give you directly one example, guys, and we'll try to understand with the example that how the prediction process will happen, how the architecture will happen. We'll try to uncover one by one all the concept. Okay. So let's try to take example, guys. So guys, let me ask you one question. So everyone is aware of the BMI. Nowadays, everyone is very, very conscious about the BMIs, right? So can anyone quickly tell me what is BMI and how it is calculated? What is BMI and how it is calculated? Quickly, guys, very, very quickly. I expect answer from you guys. So everyone is nowadays watching their BMIs. Everyone become very health conscious nowadays in the arena of the AI. Body mass index, awesome, awesome, guys. Dharam sir, awesome. Shalini, thank you. So guys, can anyone tell me exactly the formula for body mass index? Okay, BMI. Exact formula, yes, weight divided by height square in meters. Awesome, awesome, guys. Awesome, Abhay sir, thank you. Thank you, guys. Thank you. Thanks for your response. It was kind of a wake-up call. I wanted to understand you guys are there with me. Okay, so I am sure I'm very well aware that you guys are understand the BMI, and I just wanted to make a kind of efforts to make it more interactive or more engaging session. Okay, so I know you guys are already aware of the BMI. So guys, now let's take the example that I want to prepare a BMI, or I want to predict the BMI, guys. Okay. So I want to prepare predict the BMI. And guys, in order to predict the BMI, let's imagine I'm passing some kind of input information. Okay. So what is my formula? Weight divided by height square. Okay. So let's imagine this weight divided by height square. This is small formula. So this is a small formula. Or let's imagine that now I want to predict my BMI in certain other way, kind of other information I want to pass upon. Let's try to understand. I have a, something called as this kind of a structured data out here. So this structured data, this table I am passing, and guess what I am passing here, guys? So let's try to understand some kind of a features or some kind of columns, and based on this information, I'll try to predict my BMI. Okay. So this time we're going to make some small efforts to make it more progressive, make it more understanding. So what I'm going to do is I'm going to pass something called as my age, guys. I'm going to pass my age. I'm going to pass my height. I'm going to pass my weight. And then, guys, I'm going to pass my gender actually. And based on this information, guys, based on this information, I will have to predict the BMI number. BMI number. My BMI number could be somewhere between 0 to up to 50. Or mostly it could be 60. Okay. It is a general range. And what I can understand is from 0 to 25, if I get a BMI number, I will be a slim person. If I get between somewhere between 25 to 35, I'll be a fat person or near, called as fat. And if I have a BMI which is greater than 35, guys, I'll be called as obese person, obese. Okay, this is the categorization is there. So in order to understand my health, in order to check my health, guys, I want to understand what is my BMI number. I want to predict my BMI number, and I am not going to use this formula, weight, height. Okay, so this kind of a formula, I am not going to. Morbid obesity. Yes, yes, awesome. Awesome, guys. You guys are already aware of all the terms, right? Gayatri, thanks for information. So weight divided by height square, I'm not going to use that information. I'm going to do it in the other way. I want to understand what is the repercussion, what is the impact of age, what is the impact of height, what is the impact of weight, what is the impact of gender. And based on this information, guys, this will be called as X. This will be called my feature. And based on this feature, I want to predict my BMI number. BMI number. And I'm passing this kind of information out here to my neural network. Okay. So let's take this example. And by understanding this example, we try to uncover how the entire neural network will work upon, what kind of calculations are there, what is the mathematics behind it. So what happens now? We have understood something called as input layer is there. There is something called as now hidden layer is there. And then I have a output layer, guys, output here. So this kind of output will be there. And this output, I will be able to get a Y height out here. Okay. So this is my 3-tier architecture. This is what I have understood. Now what I am going to do is I'm going to pass something called as age out here. So age will be passed on here. Then I'll try to pass my height. I'll try to pass my weight. And then I'll try to pass something called as gender out here. Okay. So this is what I'm going to pass. Let's call this as X1. Let's call this as X2. Let's call this as weight as X3 and gender as X4, guys. Now what's going to happen? What is the entire process and how what is called as now forward propagation? We'll try to understand, guys. Okay. So what is the entire process? How the perceptron works upon? What is the entire ANN works upon? We're going to understand the entire ANN working. Okay. ANN working here. So what happens, guys? Initially, we try to initialize the weights. Okay. Weights are initialized to very small random numbers. Okay. So these weights, what is going to happen is, let's try to understand. Let me draw this with a different color now. So what is going to happen is, whatever these circles, these neurons are there, these neurons in the first layer, which is called as input neuron, they are accepting the information out here. So we are passing age, we are passing height, weight, and gender information in kind of a rows. I am passing rows of the data. Let's imagine I am passing 10,000 records. Okay. So I am trying to pass this kind of entire 10,000 records, guys. And once I pass this record in one by one here, let's try to understand, let's try to discover what is happening. So if you are able to see carefully, guys, this kind of a diagram, what is happening? So connection of this neuron 1 is also with the connection of this neuron, the next layer neuron. Okay. So next layer neuron is then neuron number 1. This is layer number 1 and neuron number 1, L11. This L1 has a connection with the second layer, with the first neuron, with the second neuron, with the third neuron, with the other neuron as well. Similarly, X2 also has a connection here, and here. And this also has a connection here, and here. And this X4 also has a similar connection with everywhere, with everyone. Okay. So what is happening here? Try to understand what is happening here. What is the information? Whatever information I'm passing, that information is getting this kind of a thin lines, which is called as connection now. These thin lines are called my weights. Okay. There are weights present. So this weight is not the single weight. I can call this as a weightages. These weights are present everywhere. Whatever these thin lines are there, that many weights will be possible. That are weight are possible. That weights are available here. So I'm just trying to call this as weight number 1 now. So for X1, I will be having one weight number 1. X2, I will be having weight number 2 here. Weight number 2. There will be weight number 3, guys. So I'm going to explain you only one neurons working, and similar neurons working will be repetition out here in all the neurons. Okay. So there is something called as weight number 3 here. and there is something called as weight number 4 here, guys. Weight number 4 out here, present, which is present out here, and this is nothing called as our connections. Actually, these thin lines are connection, and same connection are also present here, guys. Same connection are also present here. So every connection is available out here. So I can write that after W4, this is also something called as W5 available here. W5, okay. And then there is the output layer, and then I getting a y hat prediction, my prediction, okay. So let's try to understand, let's try to imagine what is going to happen here. So what it says that the learning says that first you have to initialize your weights. How everything starts, you guys are already aware, gradient descent algorithm. Everything starts with the random guesses, okay. So we are giving random numbers to my weightages, some random number are given, and once I give my random number, my working will start, guys. What is going to happen? Let's try to understand. There is a two-step process happening. Let me rub some information out here, and I can make you understand what kind of a process or what kind of a calculations are happening out here. So meanwhile, guys, I'll try to rub this BMI information out here, and here I will try to write something called as my two-step process out here. So let's try to understand this one, my two-step process, something called as my two-step process. So guys, in this neuron, let me draw it here. In this neuron, guys, this circle, this perceptron, there is a step 1 and step 2 happening. Something called as step 1 and step 2 happening in the hidden layer, guys. So what is happening in the input layer? Input layer just take the information. It just accept the information. It is getting passed on to the next layer, which is called as hidden layer, which is our nucleus, and which is able to perform the application, which is able to perform the processing. Okay. So let's process this information. Let's try to understand this information. What is going on here? So what happens is the moment I pass the information, guys, there will be some kind of a multiplication value. So whatever age I am passing, it is getting multiplied here. It is getting, let me draw that with the different color so you guys will be able to understand that one. Let's take this color. So whatever information I am passing here, okay. So x1 getting multiplied with the weight W1. So x2 getting multiplied with the weight W2, x3 getting multiplied with the W3, x4, sorry, get multiplied by W4. And let me write the same situation. Let me write the same formula out here. I'll call something as y, and step 1 is happening now. So step 1, what is happening? Let's try to understand what is the first process happens. Initially step 1 is actually we are trying to initialize my weights. Once my weights are initialized by using some kind of a small random number, then I'm trying to perform some step 1. Some step 1 is called as summation of W into X. W into X, and let's try to understand what is the summation of W into X, okay? W into X, something called as W into X means what? This input X1 I'm passing, okay? Let me write it here. So whatever X1 I'm passing, X1 is getting multiplied by W1. Then I'm trying to sum it, okay? Because here, whatever information you are seeing everywhere from this input, from the first neuron, second neuron, third neuron, fourth neuron, every information which is getting multiplied with the weights, it is coming out here in the first neuron because that many connections are available. So what I'm trying to write here is first information is happening is, so x1 getting multiplied by w1, x1 gets age gets multiplied by 1 weight, and then plus what I'm going to do is I'm going to get something called as height, and height get multiplied x2 get multiplied by w2. Then I will have a something called as my x3, which is my weight. X3 get multiplied by W3, and then I have something called as my gender. So my gender information is stored in X4 variable, which is also getting multiplied by W4. So this kind of a information multiplication and the summation is happening, guys. This is called as step 1. I am trying to store that equation into something called as Y now. Okay, Y, and I can simply call this Y equal to summation of, so X stands for all the X and W stands for all the weightages, and I equal to 1 to, and this is what is happening, summation of individual multiplications. All the individual weights are multiplied by the individual inputs, and that is getting summed up. Okay, this is what is step 1 happening. Now what is comes as a step 2 now, guys. Step 2 is something called as activation function. Now activation of Y actually happening. Activation of Y. What is Y? Y is nothing but it is a summation of individual inputs into the individual weights, and I'm trying to sum them up. This is called as Y, guys. Now then I will write something called as step 2 now. In step 2, what is going to happen is, so step 2, I will write something called as Z now. So Z equal to activation. Activation function will be introduced out here. So one activation function will be there. Activation of Y will be happening. Why activation of Y? Because let's try to understand. Whatever information X into W I passed in. Now I have to take decision. Input has been become now prominent in my neuron. My neuron has received some information. Dendroid has passed information in the nucleus. What nucleus does, guys? Once the information is passed from the neuron, let me ask you guys only. So once I pass the information from the dendrites to the nucleus, what decision it takes, guys? Tell me, please. So if you are able to understand the biological neuron, what information or what process it will do next once it receives the information? Cell body nucleus. what it will try to do next, guys, once it is able to receive the information from the dendroid. Can anyone tell me what will the next step happening here? Once the biological neuron, they try to receive the signals. So what will be the next step they will be doing, guys? Guys, come on, quickly, guys. Please tell me. We have only 5 minutes, 10 minutes, sorry. So we have to make this session, continue this session. Please try to tell me what is the next step which happens in the biological neuron once we receive the signal, which is called as information to the dendrites. So what is the next task done by our biological neurons? Can anyone tell me? Okay, Abhay is saying will perform action if it comes from 2, it will perform the action. It is a false, then it will not perform action. Awesome, guys. Or something called as about the activation, about the triggering. We spoke about the trigger, whether to trigger that information, right? Yes, Dharam sir, correct. Data processing will happen. So something called as related to triggering will happen, guys. All right, awesome answer, guys. Awesome. Thanks for confirmation. Thanks for answering. Okay, so awesome. And one more. Okay, fire. Awesome, Abhay sir. So this is what actually I was asking for. So what will happen is I will try to understand once my information is there, once I receive my information, and I'll create something called as some function called as activation function. This activation function will try to trigger the information. Triggering the information will happen, guys, immediately once the information received. Trigger the information. Trigger the information means whether to trigger yes or whether to trigger no. Okay, yes or no. This kind of a decision has to be made, right? So once I receive this input, guys, age, height, weight, and gender, and whatever the processing is happening, multiplication of weights into the individual weights, into the individual inputs, and then I have to decide whether to trigger this information to forward or not. Okay, this is what is called as activation. So whether to activate this neuron, whether to deactivate this neuron, this is going to happen. Okay, so that is called as trigger process. Whether to trigger that information, whether not to trigger that information, and based on the weightages, based on the pattern, based on the calculation, either it will try to fire the signal, it will not to fire the signal, and this is what the activation will do. So this activation function, let me write some information about the activation function and what the activation function does. So there comes the activation function into the picture. I'll call something called as activation, ACT. So activation will try to perform 3 unique operations, guys. One information it will try to perform something called as whether to activate that particular neuron or not to activate. Okay, activate or no. This is what I'm going to write. Okay, in shortcut, guys. Activate or not to activate, triggering the information. Then second information or second task which will be done by this activation function is, guys, something called as scaling. It will try to scale or normalize the things. Scaling means what? Let's try to understand. Whatever information I'm passing from minus infinity to plus infinity, guys, whatever data I'm passing, it will try to transform that data. It will try to perform a transformation. That transformation could be something like, guys, it will try to transform between 0 to 1 possible, or it will try to transform between 0 to plus infinity, or it can perform a transformation from -1 to 1. So you pass any positive number or any negative real-time number, it will try to convert that number into 0 to infinity, 0 to 1, or something called as -1 to 1, guys. So this kind of a scaling, this kind of a transformation is done. That's my job number 2. And once I perform job number 2, guys, my job number 3 is something called as non-linearization. Non-linearization. This is what is called as my third job, guys. I know it is very cluttered information, but I'll try to make it better. Let's try to understand this way. Let me denote that with the color, this color. Okay, so whatever the information I have, these are my 3 jobs of activation function, whether to activate or not to activate. Okay, then scaling, something called as scaling will be done 0 or 1, or between 0 to infinity, 0 to 1, or something called as -1 to 1. And then the last task will be non-linearization, guys. Non-linearization. Let's try to understand, because since the artificial neural network, they don't only take the structured data, just like the table we are talking about. They can take the unstructured data, something called as now images, something called as videos, which cannot be fitted into rows and columns. So that kind of information they are processing. That is why we require something called as non-linearization. So this task will be happening, guys. This task will be happening. And after this activation function, okay, now let me rough few things out here, and then make me some space out here to explain you the second step, what is happening out here, and what is the end result which we are trying to receive out of it. Okay, so once I am able to perform this task, guys, then what is going to happen is I'm going to pass this Z. This is called as Z now. This Z, we are passing this activation function, and my entire Y, which is the individual weights multiplied by the inputs, are getting passed through the activation function, and this activation function will give me something called as output 1, O1. I'll try to receive something called as O1, guys. And if I try to write it here, okay, let me write it with a bigger font now. So this O1 will be coming out here. See, O1. So this O1 will be coming here. This is called as output 1, guys. And this one, once we receive this output 1, okay. So once we receive this kind of output 1, guys. So okay. So after this two-step process, which is called as activation function passing the information of this entire information. So I going to receive something called as up to 1, and this output 1 will be the result coming out of this cell, right? So this cell will give me something called as output 1 out here. So output 1 will be generated, guys, and this output 1, again there is a W5. So output 1 will get multiplied by W5, guys, multiplied by this weight, which is the connection. And then, guys, after this multiplication, I'll receive this Y, final Y. So this final Y will be received Y hat. I can call this as Y hat, guys, my output. Okay. So this is what I prediction I'll get, and this prediction will be my BMI. Prediction will be BMI. So okay, this is what will happen. And once I am trying to get this BMI, guys, so obviously after that prediction is got, I'll calculate something called as loss function now. I'll try to calculate loss once I get a prediction. Loss will be my actual BMI, YI minus Y hat. YI minus Y hat. Let's imagine my actual BMI is 25 and 25, and this prediction which I received is 30, guys. So I'll try to write is 25, and then I am having a prediction which is 30. So there is a loss of 5. So this is becomes my loss. And when I try to combine the loss for all my prediction, guys, there I can write something called a summation function out here. Summation of all equal to 1 to n. So this is called as cost, guys. Cost function. Okay. So once I receive the cost, guys, this is what the entire process happens. And this is something called as now forward propagation. This is what the first iteration happens. This is what the first pass happens. Okay. So let me denote this entire thing with a different color now. So this is called as, guys, this is end of this. Once we try to receive this kind of a cost, we are trying to receive our prediction. This is entire thing is called as forward propagation. Forward propagation, guys. Okay. Forward propagation. Now this is not the end of the story, guys. This is just the half of the story. Now what is going to happen? Let's try to understand. Can you please elaborate about the cross function in more with cross function in more with a better example? Cross function, sir. Which activation function you are talking about, Abhay? Sao, sir. So cross function means what exactly? Actually, are you talking about this activation function as a cross function or what? So I can explain this in better way. Okay. So guys, this is called as something called as okay. Yes, sir. I'm going to focus more on this activation function. In tomorrow's lecture, we'll try to understand because we have a very limited time now. Or maybe I can start with this activation function. So I'm going to cover the entire list of the activation function, which are my activation functions available. Okay. So what are the activation function? Which are the activation function available? Out of that, how to choose the best activation function? All these things I have I'm planning to cover, guys. And if possible, now in 5 minutes is not possible. In tomorrow's session, we'll try to uncover this. Okay. So guys, until now, okay. Until now, thanks for that, sir. I'll explain this. Don't worry. In upcoming session. Okay. So because we have a limited time here, only 5-6 minutes are there. So guys, until now we have understood that I am started with understanding. Let me revise the things and let me tell you. So until now, whatever process we have seen, this is called as forward propagation. And after this forward propagation, there will be something called as backward propagation also. So forward propagation is something called as half of the iteration, half of the process, and something called as back propagation. Back propagation going to happen. Okay. So let's try to understand this one, guys. Let's try to understand and let's try to revise what our things we have done here until now. Okay. So what I have done is I have tried to pass. My entire aim was to predict the BMI. Now my BMI formula is something called as, I have to calculate the BMI called as height square divided by weight or some kind of a formula. But no, I'm not going to create that kind of a formula out here. So what I'm trying to decide is that I'm going to divide my weight by height square. No. So that is what I'm going to do. I am decided that I try to pass my age, I try to pass my height, I try to pass my weight, and try to pass my gender information. Then I try to predict how this kind of a feature are going to impact my BMI, and then I'm going to create a BMI. I'm going to predict my BMI number. This is what the process I started. And in order to start this process, in order to perform this kind of prediction, what I've done is I have created one neural network. This neural network has a 3 layers. One is called as input layer. One is called as hidden layer out here. This kind of a neuron, and something called as output layer out here. Output layer. Okay. So for that purpose, I pass my age, I pass my height, pass my weight, and pass my gender. Those are respective called as X1, X2, X3, X4. And there is a 2-step process which happens here. This is what we spoke about. Step 1 and step 2. Step 1 and step 2 process happen. In step 1, guys, what is happening is step 1, what is happening? Once I pass this age, once I pass this height, once I pass my weight and gender, this is getting multiplied by individual weights out here. So these thin lines, thin connection are there. This connection are called as my weights now. Okay. So once these weights are available, and how I try to start? I am trying to start with the random initialization of the weights and with a very, very small number. And once I initialize all my weights with a small number, I am going to create a two-step process in the hidden layer, which is the processing. Step 1 process. Step 1 process is something called as my y. I am going to calculate my y. Y is nothing but x1 multiplied by w1 plus x2 multiplied by w2 plus x3 and so on. And once I perform this, I can call this as a summation of x into w. Summation of x into w. And once I get all summation, I equal to 1 to n. And this is my step 1 happening. I receive something called as y now. And that y in step 2, what is going to happen is I am going to calculate something as z now. That is my step 2, which is called as step 2 here. And step 2, I am going to pass my y, whatever the y is there, through the activation function. And this once it is passed through the activation function, guys, and you guys already, I have listed you the function. That activation function will decide whether to trigger or not to trigger, triggering the information just like the human brain, human functionality, and yes or no. And then based on that, I'll receive something called as one output here, O1. So once I receive out of this entire hidden layer, guys, O1 here, the O1 will also have a one more weight available here, W5, that will get multiplied by W5. And then, guys, after multiplication of W5, I will receive something called as my Y hat in output layer. Y hat my prediction, and the Y hat is nothing but my BMI number. Once I receive my BMI number 25 and actual BMI is 30, so there is loss actually. So I am calculating my loss now. So what is my loss? Yi minus actual minus predicted. So 25 minus 30, which is 5. So when I am trying to calculate for the one instances, when such instances are summed up together, that is called as my cost function, cost. Okay, once I get the cost, that entire process until now, guys, here called as my forward propagation. And this is what the forward propagation happens. And this is what the mathematics happen in the background in the artificial neural network. And this is just the half journey. This is just the half journey, guys. And after that, the real process starts and real learning starts. This is just the process where we are not doing anything. We are just trying to sum up the information. We are passing the information layer by layer, information happening. And whatever process has happened here in the hidden layer neuron 1, same process will happen here, same process will happen here, same process will happen everywhere, guys. Okay, same process will happen everywhere, and similar process will be combined, and then we'll get our combined result y hat. And this is just the half process, forward propagation. This is called as forward propagation. Then the actual journey starts, and let me denote that journey with a different color now. Let's me denote this with a dark color, green color. And once I get my cost, guys, then it's the actual learning of the model will start. Which will start with the cost function. It will try to visit something called as my prediction here. So let me draw that with the green color now. You can see the green arrow out here. From the cost function I have started, and from cost function I'll go back to my prediction. From prediction, guys, I will try to go back and try to propagate back towards my inputs. The way I have received, I perform a propagation. I started from age, I received to the input layer, I went to the multiplication of weightages, and then went into the hidden layer. Hidden layer processing happens, step 1, step 2. Then I received my output, and then I received my prediction. Prediction got loss got calculated into the cost. And from the cost, I am going back now. One entire iteration is called as now forward propagation. And after that, my backward journey will start. And then that is where the actual neural network will start the learning process. And this learning process, the effort of this learning process will start from the cost function, visiting back my prediction. From prediction, I am going to cover my output O1. From output O1, I will try to understand what is my weightages 5. From weightages 5, I am going to my hidden layer, and I will try to visit all my hidden neurons. And from hidden neurons, I will try to go to my weightages, individual weightages, weight number 1, 2, 3, 4. And then once I visit all my 1, 2, 3, 4 weightages, I'll try to go back to my entire initial parameters, which are my inputs. And this backward journey, this entire backward journey, when I'm trying to propagate through my entire backward journey, guys, I'm trying to learn that what went wrong, that I received my loss. What went wrong? Actually, I am supposed to receive 0 here in my loss function, but I got something called as 5 here. What went wrong? I need to investigate, and that investigation process will be called as a backward propagation. And in the backward propagation, there will be concept called as optimizer, which we have learned in our machine learning. We still will try to cover once more. All the optimizer's job is to optimize the loss, so it becomes very, very close to the 0. And that is optimization will come into the picture. And with the help of the optimizer, entire my investigation journey, my journey backwards to reach towards the input will start. And it will try to investigate what went wrong and what is the problem that I am getting. this kind of a error, this kind of a differences, which is 5. Okay, and once I try to receive this information, I will try to investigate, I will try to recover my calculation, and I will, in efforts to recover my calculation, I will try to update all my weightages again, and I will try to start fresh with the same process again. So same process will be started with the fresh updation of the weights, and this many iteration will go on, and in the final stage, we'll receive our final prediction y hat. After multiple iteration, multiple epochs, we'll get our final y hat, and which y hat will be very, very close, and which will be the difference of the loss will be very close to 0. And at that time, you will be able to achieve the exact prediction, and your accuracy will be around 90 to 95 after multiple epochs, multiple iterations. So this is how the entire artificial neural network will work upon. So guys, now it is very interesting to see what this backward journey look like, what kind of a processes happens, what kind of a mathematics happen, what kind of a derivatives are taken, what kind of a techniques are used, what is activation function, what kind of activation function exists, what kind of a loss function exists, where to use what kind of activation, where to use the loss function, which kind of a loss function has to be used, what kind of a optimizer has to be used. Once we are able to understand this entire mathematics, then we can understand the problem with the artificial neural network, and we try to calculate, or we try to perform something called as regularization, means penalizing our neural networks, and then we try to make a code walkthrough. All right, guys. So I hope you guys have enjoyed this entire journey, the entire web episode number 1. So today's web episode, so which we try to uncover the journey, and still the excitement part, or the pinnacle of the excitement yet to come. The moment, the part of the moment which is called as the backward propagation. So tomorrow we'll try to start with the backward propagation. We try to understand the activation function, like the sir requested. We try to understand all the activation function, loss function, all the optimizer they're working, and then which is the best, which is not to choose, what not to choose. And we'll try to build our small application with our neural networks, with the image data, and for the unstructured data for the image data, and for the structured data, bank churn prediction. And then we'll try to move forward to the computer vision, guys. All right. So this is what going to be future steps for us. So hope you guys enjoyed this entire session today, and I wish you guys best of luck, so you guys can also continue your learning path the same way, and we'll try to uncover the next topic, guys. All right, guys. So thank you very much, and I will try to conclude my session here. So let me stop sharing, and hope everyone has marked their attendance. So attendance link is already shared, guys, with you, and 60% attendance is compulsory, mandatory to get the certifications, guys. And hope to see you next session. All right, guys. That's it from my side for today. Thank you very much. Good night, and see you in the next session then.
Yeah, thank you, Vikas. Thank you for the wonderful session. Yes, guys, hope you enjoy the session. Please let me know, is there any query regarding LMS? And I'm sharing the feedback link in the chat box. Please mark your attendance, both YouTube and Zoom as well.
Yeah, guys, please let me know in the comments if you find the session useful. Please let me know your comments, and for 1 minute or so, we'll try to be live. And if no question, no doubts, then we'll try to close. Any doubts regarding LMS, any technical issues, you can ask Chandana. And any related doubts related to session, you can ask me, guys.
So I'm sharing the registration link as well. Please register. Who is not registered for the application? So I hope there is no more questions. Abhay Sahu, the session was good, but it found it a little bit fast.
Okay, sir. We'll try to cover all the things again. Okay? Any other question?
Sharon sir is asking, sir, kindly use a separate sheet for explanation.
Yeah, okay, sir. We have a slides. We'll try to explain because today's time was less. So I just given a hint. I will try to cover all the things, all the details. Yes, we have a detailed slides everywhere. Don't worry, sir. We'll try to explain the things again, all the calculation with the separate sheets.
Okay. I hope there is no more questions. Yeah, thank you. Thank you, sir. Thank you, everyone. Okay, Vikas, we'll wind up the session.
Okay, thank you everyone, and we'll try to cover all the things. I will take your suggestion. I have a separate slide, don't worry, for all the calculation. We'll try to uncover all the things. We'll try to brush up all the recap, all the things, and we'll try to continue our discussion tomorrow. Thank you very much.
Yeah, thank you.